Hello, welcome to Mathematics. So this is actually part 2 of our previous video. So if you haven't watched part 1 yet, you all can find the link in the video description. Alright, so let's go to part B. So they're changing the focus a bit. Now they're focusing on each of customers. And it says it follows a normal distribution with this mean and this standard deviation. So again, here it's just a value, does not give us any significance or meaning. Alright, so there is this campaign and the restaurant would like to distribute these food vouchers to those which are aged 18 to 21, which is the teenagers based on part A. Right, so they're asking us if there were 500 visitors that day, what is the number of food vouchers distributed? Right, so this means from these 500 visitors, how many of them are teenagers? Okay, which also means what is the percentage of teenagers in these 500 visitors, or also means what is the probability of teenagers in 500 visitors. Right, so to find this probability, we can use this normal distribution to help us out. So again, to find probability same as binomial distribution, we need to have 4 steps. So the first step is to determine our random variable. So here, this random variable I actually referred from this first sentence because it says each of customers follows a normal distribution, right? So I just use this as x. So step 2, we need to find the distribution. So here it says normal, so I'll put n here. And step 3 is to insert our parameters. So the parameters here is actually mu and sigma, right? So mu here, in other words, is mean, and sigma is actually standard deviation, right? So I just put the parameters here, 34.5 and 12.75, right? So this part is a requirement, yeah. This one is actually variance. So as we know, standard deviation, if we square, it will be the variance, so I just put a square on top. Right, and the symbol for variance is actually sigma squared. And lastly, we go to step 4, which is to find the probability. So again, the probability that we need to find is when x is between 18 to 21. So to find probability for normal distributions, they will be a bit complex, so I split it into 3 parts. Right, so the first part is actually to standardize these values 18 and 21. Right, so let me show you how do we standardize first. So if our x is 18, we minus the mean, which is 34.5, and we divide the standard deviation, which is 12.75. So same goes to 21 as well. Minus mean, divide with standard deviation. So the x, if we standardize, it will become z. Right, so why are we doing this? Okay, so let me give you 3 situations. Let's say the first situation is the one we have now. The second situation is I changed the mean a bit, but I remain the standard deviation. The third situation is I maintain the mean, but I change the standard deviation, let's say to 12. Right? So without this standardizing method, the way that we need to find probability would be, so in your exercising book, you will see a table which has a lot of values, right? So that is actually a normal distribution table, and we need to use those tables to help us find the probability. So imagine for that table, the parameter is 34.5 and 12.75. So if we have that parameter, I can use that table to help us find the probability. So if we slightly change the parameters a bit, let's say mean, which is in the second situation, we cannot use the table anymore. We need to find another table which has mean is 34 and standard deviation is 12.75. Same goes to the third situation. We need to find another table with these parameters. So imagine if I can tweak even more situations out. So there will be a lot of tables that we need to refer. So it will be a bit troublesome. So what we do is, for all these parameters, I change it, or meaning I standardize it, so that all the situations I will only refer one single table. So this is the big role for us to standardize the x values to become z. So we only need to refer one table, which is the one you see now in your exercising books. Right? So if we standardize here, we will obtain these values. So this is the second part to find probability, which is to draw our graph. So this is actually a normal distribution graph and it's bell-shaped. Alright? So if you look at the left side and the right side, both of them are actually the same shape. So this is a symmetric graph. Alright? So let us plot these two values inside here, and we need to sketch our area out. Right? So here, take note here, the area of shaded region is actually our probability. Alright? So now, the probability that we need to find is here. So I will always have two checks. So the first check is make sure the area starts from the right side. Okay, so this means the area must come from here, from the right side. The reason is because from those tables I mentioned just now, we can only find probabilities if the graph has this kind of pattern. Okay, so this is why it is our first check, right? And the second check is our areas must only be on one side. It can be on the left only, on the right only. Right, so here is only left. Okay, so we passed the second one, but we failed the first one. Right? So what we need to do is let's move this area to the other side. We can do that because it is a symmetric graph. Right? So if you move it, it will look something like this. So the values will slightly change. These two values from negative will become positive. Right? So again, to find the areas using the table, our graph pattern will be something like this. Okay, but now it's different. So what we can do is, I will first consider the area which is more than 1.059, which is all the way to the right side. Okay, so if I draw it out, it will be something like this. Okay, so this is exactly the type of pattern that we can use a table to find our probability, right? And the second part, because we need to cancel off this white color part, so the same way as well, I only consider the values which is more than 1.294, and to find the probability, let's say it's here, right? So to find our area here, I can minus off these two areas, right? So here I will write, for this part I will say PZ more than or equal to 1.059, okay, which is the values more than this 1.059, and I minus off this area, which is P when probability of Z is more than or equal to 1.294. So our first step is to refer to the table to help us find the probability. Alright, so this is the standard normal distribution table. And now to find the probability, as you can see here, these are actually our probabilities. So to find them, we need to separate our value into three parts first. Okay, so I will split it this way: 1.0 as one part, 5 as one part, and 9 as one part. Alright, so to find, for this 1.0, I will look through the first column first. Right, so here I will search for 1.0. Okay, I found it. And for the second part, which is the 5, so for the second part, I will refer to these columns. And I would refer to the column which has 5. Okay, so by looking down from here and by looking to the right side, the value that we need to find is 0.1469. Right, so don't forget we have another value which is 9. So for the 9, I will look through these columns and I will search the value 9. Okay, so by looking down and looking at the same row, so the value will be 21. So for these two values, what I will do is I will minus them together, right? So 0.1469. Okay, so this doesn't mean I minus 21. This means this 21, we need to write it from the right side first. Okay, so this 21 is actually 0.0021. 0.21. Right, so if we minus off, we will obtain 0.1448. Right, so this is our probability. So I'll let you all to have a few seconds to find the probability when our value is 1.294. Alright, so the two values, I hope you have found the right one, which is 0.0985 and the other one is 7. Right, so the 7, again, you need to write it from the right side, and here we need to minus 0.0007. Right, so our probability will be 0.0978. Alright, so if we obtain our probabilities and minus them together, we will obtain 0.047. So this value means that among 500 visitors, 4.7 of them are teenagers. Okay, so if we multiply these two values together, we find out that the number of teenagers are 23.5. So again, it's not logical that our number of teenagers is 23.5, so we need to round it to the nearest whole number, right, which is 24. And with that, we have completed today's question. Alright, so here's the take home point for part 1 and part 2 of this video. So for the first point, when we are finding probability for binomial and normal distribution, we need to follow these 4 steps. Okay, so for the first step is to define our x. The second step is to determine the distribution of x, either it is binomial or normal. And step 3 is to find our parameters. So for binomial, it will be n and p, normal will be mu and sigma, right? And step 4 is to find our probability. So this brings us to the second take home point, the things we need to take note when finding probability. So for binomial, make sure the question's perspective and our perspective is the same, otherwise we cannot find, right? And for normal distribution, we need to follow this tree. Okay, so the first thing is to standardize our values from x to z using the formula. The second one would be to draw our graph, the probability distribution graph, or the bell-shaped graph, right? So we need to have 2 checks. So one of the checks is to make sure the area starts from the right side, and the second one would be the area must only appear one side of the graph, so either it's on the left side or the right side. And the third thing is make sure you are able to find the probability according to the value given, right? So the table I'm referring to is the probability distribution table. Alright, so here is the answer scheme for this question, and hopefully you have learned something new from this video. Right, so if you feel this video is beneficial to you, please give a like, subscribe and share. Okay, thank you so much for watching, and I'll see you all in the next one. Bye bye.